This here is a room on a house that was really hard to get at in the attic, and they just didn't blow it. They didn't insulate it.
And this was 5 years later. We went in with the infrared camera, a lot more than five.
No, the original, this is about a 40-year-old house. So for
Yeah.
for 35 years it was uninsulated. And then they had a remodel done 2 or 3 years ago and had like this much insulation blown in their whole attic.
So for 3 years they were wondering why their living room was cold.
Yeah.
And the infrared camera showed us that. You know.
Here's another knee wall detail. There's no air barrier on the back side of that. That's a vaulted ceiling, and then the attic on the back side. This was a really interesting image. I think this was 12 inches.
14.
14 inches of loose fill fiberglass in an attic. There's no air leakage there. All that is heat loss.
Yeah, this was a solid drywall underneath with a vapor barrier. There were no air leaks there. That's just heat coming up through the fiberglass, which was kind of interesting. Looks like a volcano.
Yeah, yeah. This is just no energy heels, which is another detail we'll get into later. But you know, with a heel, the truss sits on the wall where you have that really short, depth. Not very much depth there means not much room to put insulation, and so we see this a lot. Here's some of the moisture and mold issues we've seen. This is the wet insulation from air leakage in an attic. In this picture, it actually has dried out at that point, but it has been continually wetted and dried.
And their attempt to solve the problem was to lay a piece of plastic over the top of the insulation, which, of course, all they did was trap the moisture in the insulation, and that had been absolutely soaked. So, and what had happened here was they'd gone in and just put insulation in the attic without dealing with the air leakage. So that's another key thing, is don't go into an attic and just add insulation, right? If you don't deal with the air leakage first, what you're doing in that case is you actually drop the temperature in the attic, because most attics are actually warmed by air leakage from the house.
And heat loss, and just heat loss.
Yeah, heat loss and air leakage.
Yeah.
So the attic is actually somewhat warm, which helps to reduce the potential for condensation. So if you go in and you blow in a bunch of insulation without dealing with air leakage, all you've done is drop the temperature of the attic, which has increased the potential for condensation. And that's exactly what happened in that slide, was that they put in insulation without taking care of air leaks, and they created a huge moisture problem. They had water dripping out of their light fixtures after they put the insulation in. So what we typically do is go in and actually take the old insulation out and deal with the air leaks and then put the new insulation in. That's what you really need to do.
Here's another, you probably can't see it, but this whole attic was full of mold. Same thing. They had a bunch of insulation in there, but no air sealing, and the whole attic was filled with mold. These are the baffles right here. They've gotten so wet over time that they actually fell down, the cardboard. Another part of energy efficient construction is the ventilation strategy to deal with indoor air quality. It can be an exhaust only ventilation with a quiet bathroom fan, or heat recovery ventilation, which we're going to get into more later.
Yeah.
You can tie heat recovery ventilation systems into furnaces, or you can duct them directly to all the bathrooms and duct fresh air points to all the different family room, bedrooms in the building.
And Russ will be manning the demonstration at the back here, and he'll be going over a lot of details about ventilation strategies and stuff.
Energy efficient heating and cooling equipment, using sealed combustion furnaces and water heaters is really important. You have a B-vented water heater in a building, that means you have a big hole not only with the flue going up and out, but also the combustion air coming in. I mean, you literally have to leave 6-inch or larger hole depending on the BTUs of the equipment. So using sealed combustion, it's important as well for health and safety. If you have a B-vented water heater and you have large exhausting appliances in the building, and the building's relatively airtight, you can backdraft the water heater and actually cause carbon monoxide poisoning for the people in the building. If the easiest path for that air to come into the building is through the flue, that's where it's going to come. and those flue gases will come into the building and potentially poison people. We've actually been involved in lawsuits where people have had carbon monoxide poisoning from that exact thing. Looking at, part of the new code, we're not going to get into the lighting requirements of the new code today specifically, but there are some details.
We'll talk about it. It's pretty simple.
Yeah.
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 50% of lights have to be CFLs or high efficiency bulbs.
And then, of course, the last item is the alternative energy aspect of energy efficient construction.